All right, folks. All right, welcome back. So now we're gonna talk about more of these key aspects of Android and Android security, and you guessed it right. This is gonna be critical for the first homework. All right. So we're gonna start with talking about more aspects about things we already discussed. So in the previous class, we discussed about activities, services, receivers, and content providers, and also intents, bundle, and things like this. And now we're gonna discuss a bit more in depth these things, and more technical details about what you could discover, in the real world. So we start with activities. So last time we discussed how to start an activity. So you build an intent that specifies, a concrete action, a concrete target, the explicit intent, or a generic action, like, oh, I would like to view this URL. That would be an implicit intent. And we understood that to start an activity with the specification, you do start activity and you pass the intent as an argument. Okay. It turns out that activities can also get an answer and return a result. Okay, so now we're going to see how this stuff works. Let's say the scenario is that you have a component a.x, so application A and activity X, and there is another application B which has activity Y. Okay, and let's say that a.x wants to somehow start b.y, but also somehow get a return value. Of course, B could actually be also the same application. So this is more to make it more generic, but of course they would work also intra application. But for the sake of being generic, let's say a.x and b.y. Now, as we know already, we create an intent that specifies b.y. The difference here is that we use start activity for result Android API instead of start activity. And as you can notice here, we also need to pass not only the intent, but also a request code. Maybe unclear why we need to use this request code. Is going to be clear in a second. Okay. So if we do this, then on the aspect of starting b.y is going to be the same as start activity. So the Y activity of application B is going to be started. And if the first time that it started, then the onCreate method is going to be called, and then all the other ones, as you've seen last time. And then what now Y can do is to create another intent and somehow return it. So the way it works is that you do result intent equal new intent. So now you create a new intent object, and then you can use this set result API. And here you see we need to specify some kind of return code, and then we pass to this set result the actual intent, and then very important, we need this for the homework, we do finish. At this point, what happens is that the activity X somehow is going to be a callback of activity X is going to be invoked. This callback is on activity result and accepts 3 arguments: request code, result code, and data. And these arrows somehow map what you're gonna find in these 3 arguments. Okay, so rephrasing what I'm saying right now is that if you focus on the activity X, so the part on the left, what you do is to somehow have a code in your onCreate or whatever method you want that somehow start an activity using start activity for result method. And then in activity X, you also need to implement this callback on activity result. On activity result is a method that the framework is going to invoke whenever the target activity or a target activity is going to reply to you with an answer, with the result. Okay. So now I want to explain why do you need this request code or return result code or data and so forth. So first of all, let's start with the data. Well, the data is the intent that the target activity has created. So this callback somehow will be able to access this data or the intent that the target activity created by accessing this data intent. That's very simple. And then the confusing part, you have 2 codes, request code and result code. Okay, result code is actually not that difficult. It is basically the result code that you set up with the set result method. Okay, so if you do result okay, then somehow this result code is going to be activity.result okay, and so the callback here can have some logic saying, okay, if result was okay, then do this, otherwise do that, okay? The last thing is this request code. And in this case, we put, okay, request code 400, and then this number is gonna be coming back here. Why? So what's going on is the following, that you have activity X, but activity X could have logic inside activity to start a number of different activities. Okay, you could have some, you know, if you click one button, maybe you start activity Y. If you click another button, you start activity Z. But there is only one on activity result callback. So somehow the trick is that, you know, the question is, how can this on activity result understand which activity returned the result? Was it Y or what is Z? So the idea here is that we can use this request code to differentiate different activities replies. So for example, if we need to start Y, we would say, for example, request code equal 400, and then we do start activity for result with 400. And then here in the on activity result, we can do if request code equal 400, then do this. And we know that we are here only if Y was returning something. And in a.x, we could also have some other logic that says, you know, when we want to start activity, you know, c.z, you can do request code equal 401, and then start activity for result, an intent pointing to c.z, and then request code, which is now 401. And the idea is that now on activity result is going to be invoked when c.z replies, but it's going to be invoked with request code 401. So now in this on activity result callback, you can put some logic that says, you know, if 400, then it means it was a reply from b.y. If 401, it means it was a reply from c.z. Okay, so somehow you use this request code to differentiate different start activity for result invocation, and somehow differentiate the different replies. Okay, while the last two are basically what the set result API is returning. Please pay attention to this one, to this finish. There is one of the challenges for the homework where you somehow need to reply to an activity, and one of the problem of previous students was that they were doing set result, but they were not doing finish. So this actually sending back the reply is only triggered by the Android framework when you do finish. So please remember to do so. Cool. All right, so some more notes on services. To start a service, as I think we didn't see it last time, I mentioned that you can start a service, but the way it works is very similar to activities. What you do is to create an intent. In this case, intent must be explicit intent for security reasons. We're going to go back on which security reasons in a second. And then once you have this intent, again, explicit means you need to specify which is the target service you want to start. So package name and then class name. And then you do start service with intent. This is going to start the service. One question is, how can you how can you get back a reply? Turns out there is no analogous of this start activity for result. There are some ways to get back a reply, a result. The easiest, let's say if you want to be fast, is this broadcast intents that we'll see in a second. Okay. One note about these security reasons. The problem could be that if it's implicit intent, it could be that, forget about what this view, it was a huge spoiler. Let's say that you use an implicit intent, okay, and you want to start a service. If you use an implicit intent, the implicit intent somehow encodes, you know, I would like to execute this action. And it could be that there is not only one service that somehow needs to execute, that can handle the execution of this action. So let's say there is action Peppa, where it could be that there are two services that somehow are able to execute action Peppa. And the problem is that if you use an implicit intent, the system doesn't know which one to start. And also could be that, you know, maybe the first one is the legitimate one, and then a malicious application could define a service that somehow handles action Peppa, and somehow it would be able to somehow hijack this service activity, or, you know, somehow get access to private data that this intent of the caller would contain, and so forth. So to make sure there are no tricks like this, then the Android framework forces the start service to use an explicit intent. So the caller needs to specify exactly which service needs to process the specific request. And yeah, the use poller was, why is this not a problem for activities where you can use implicit intents? Well, because if in your system there are two apps that can handle the same action, you're going to see a choose dialog, a kind of pop up that tells you, there are multiple apps that can serve this request. Which one do you want to choose? So somehow the user has a way to say which one to use to process a certain request. With services instead is different, because services are done to perform actions that they do not have or they are not necessarily connected to a graphical user interface. So in theory, something that could happen in the background. And so this kind of dialogue thing would not really fit there. Okay? So remember, if you need to start a service, explicit intents is the way. So the full story about services is a bit more complicated. There are, I kept saying, services are something to use when you need to do something in the background. It turns out there are three types of services: background, foreground, and bound. And I want to go through them because they're actually used by real-world applications, and the full documentation is at this link if you are curious. So very quickly, background services are those that perform an operation that is not directly noticeable by the user. Okay, they can be started with the start service, and the way it works is similar to activities. You call start service, and then the framework is somehow understanding which service should be started. Once it's selected the service to be started, let's indicate this with S, it's going to invoke s.onCreate and then s.onStart command and so forth. Again, if you check documentation, you're going to see the diagram with the life cycle of a service, so you know which method is called at which point. Okay, quite easy. Foreground service is a bit different. It performs an operation that is somehow noticeable to the user. And, it's something that happens in the background, but it doesn't mean it's not noticeable by the user. And a classic example is a music player. Okay, you want the music player to somehow play some music, but there is no graphical user interface, or there may not be any graphical user interface while the music plays. So maybe it plays in the background. So somehow, that's an example. The way you start it is similar. You do it with start service, and then you call start foreground. Okay, from the service on create. Okay, and again, if you check documentation, you're going to see that the life cycle is quite similar. And now the bound service, these are actually tricky. We can say that the service is bound when an app binds to it by calling bind service. And we can also say that you can have, with these bound services, you can have client servers, IPC-based interaction. Let's try to understand what it means. You can have client servers IPC-based interaction. Well, IPC stands for inter-process communication. Okay, and these bound services are useful when you have service A that wants to communicate with service B, but it's not just a one-shot message, but it wants to be some kind of channel that is established or bound, and somehow these services want to have some kind of, message received. I send a message and I receive a reply. I send a message, I receive a reply. Some kind of channel that works both ways. Okay, or not both ways, but you can send something and get back a reply. With the starter services, with foreground services or background services, that's not really the case. You just start the service either in foreground or background, and that's more or less it. With these bound services, you have a way to somehow send a message and get some acknowledgement, get some reply. Okay, and in technical terms, we say that the service A is bound to service B. Okay, or a component or an app A is somehow bound to a service B. Okay, the way it works here is that instead of using start service, we use bind service. You basically do bind service, and then the framework is going to invoke on a target service on create and then on bind instead of on start service. Okay. Again, if you check documentation, you're going to see which method are invoked in a very nicely well documented way. Okay. But let's try to dig a bit deeper. There are three ways of implementing them. Local service, this is for only the intra app mechanisms. It's quite easy. Again, check it out. Using a messenger, it's quite complicated, and using ADL is also complicated. So in the next slide, we're going to local service are easy. Messenger, we're going to focus on this in the next slide. And ADL basically is some kind of abstract language that define interfaces, and then somehow the Android Studio can take this kind of language, high-level language, and create code automatically, both for the client and the server, so that the client and the server can communicate. I mentioned this ADL last class, where we discussed how, when you had the proxy and the stub, and how some methods are, some Android framework APIs are implemented, like I think was some location related APIs where you call a method on the client side, and somehow this invocation is through binder reaching the server side invocation of the API. And again, if you check the slides from last time, you're going to see there were two components, the proxy and the stub for binder. These components were automatically generated starting from an IDL specification. Okay, I think I have more slides later on during the class, but that's more or less the gist. Again, it's documented, but I guess I hope it's clear what kind of role this ADL has in the ecosystem. So going back to Messenger, it's a bit tricky, so I'm going to try my best to explain it. I think I'm not going to be able to explain it 100% at your satisfaction level. I think the best way is to actually try to implement something. Turns out there is one challenge that forces you to do so. But I'm going to try my best. So first of all, let's start with the first part. So let's say that we have, the caller creates an intent, an explicit intent to start a bound service or a service he wants to bind to. And then on the caller side, we understood that you just do bind service. Bam. Now on the receiver side, and that's what we're seeing right now. On the receiver side, we have this, so the target service needs to implement something like this, on bind, callback. So again, it's a callback, which means that you define it, but it's the framework that automatically invokes it when an application is binding to your own service. And the way it works, or the way you're supposed to code this, is that you need to somehow create an instance of an incoming handler. And check it out, incoming handler is a class that you need to define that extends a handler. So somehow you're supposed to create a class that extends a class handler. And this class is supposed to have a method or a callback called handle message that does something. Again, we're going to go back to this in a second. And then going back to this on bind. So you need to create an instance of this incoming handler, again, which is a class that extends handler. And you need to pass this instance to an instance of a messenger. Again, it's a bit complicated, but basically what's going on is that you need to create a messenger, which is a class of Android, and somehow inside you put an object that can handle a message. I'm going to rephrase it a bit. You need to create a messenger which contains a class inside that somehow defines the callback handle message. Okay. And then once you get this messenger, you need to, this onBind method, you need to return messenger.getBinder, which is going to return an interface of name iBinder. Again, it's a bit complicated. If it's not clear at one shot, it's absolutely normal. So try to listen to this part of what I'm saying maybe 2 or 3 times, and then check the documentations, then come back to this. And I hope at the end, everything is going to make sense. If not, of course, send me an email. Okay. But the idea is that once the service receives an invocation or with this bind service, you need to somehow create this messenger that wraps an object that can handle a message, and that handle message is going to be invoked whenever there is a message that is sent to the service. And that's where we hit this piece of code. And you need to return an iBinder object. How do you do it? You do messenger.getBinder. Okay. Again, going back to this ender message, you can copy the structure, and this ender message is the actual logic that is executed once you receive a message. And in fact, if you see, the argument of this ender message is an object of type message. This is an object that can be sent by the caller. Okay, so an app can do bind service to your target service, and then you can do send a message, quote quote, send a message, and then this message is going to be delivered to this ender message callback, and somehow is going to be available here. Okay, and then inside you can do, this message again is an Android class. Check the documentation. There are several fields. One of them is the what. So you can do message.what, some kind of code, and then you can somehow differentiate through the various cases and reply in one way or in another one. Okay, cool. Now, this is on the caller side, and the way it works is that you need to somehow define so basically service connection is a class. Okay, you need to define a new instance that implements the onService connected, and basically then you need to you assign this new instance to this M connection. And you remember when I said you just do bind service? Well, of course I lied. It's a bit more complicated. So when you want to do bind service, you cannot just specify the target intent or the intent that specifies the target service, but you also need to specify an object that is going to be let's say the handler of the connection when the connection is established. Okay, so let me have the full code here. Let's try to understand what's going on. So you do bind service with the intent and then an instance of this M connection or M connection. M connection is somehow an instance of the service connection where you define a concrete implementation of the onService connected method. Okay, conceptually this onService connected method is invoked when you try to do the connection and the connection is established. Okay, and look at this. This onService connected method somehow needs to, these are fields of the class. Okay, so these are local fields to your class. You want to save this so that later on you have basically this onService connected is invoked. You're going to get some arguments. These arguments are going to be your handler to somehow communicate with the target service. Okay, how do you obtain this handler to communicate with the target service? Well, check this out. This method is going to be called with an object called service of type iBinder. This should sound familiar. So this guy is basically going to be, going back one slide, is going to be this guy. So somehow this slide was about the one that is called. The one that is called, as we've seen, in the onBind is going to get this messenger, and then messenger getBinder. GetBinder is going to be something of iBinder, and this is going to return to the caller. And now we are here. Okay, now we are here. This iBinder is going to be passed to this onService connected, and now the caller can do this. It can create a messenger that wraps this iBinder, and now you have an object that allows you, this M service, you have an object that allows you to talk to the service you have just been bound to. Okay, once you do this, you have this M service, and now M service, you can do this, you can send a message. How do you do it? First, you define a message, and again, you define a message by using this crazy thing. You can do message.obtain. There are some arguments to the documentation, and you can define a message, for example, of type message say hello. Okay, again, this is your class. You can define, these are just numeric things. You get this message, and then once you get this M service, you can do mService.send and the message. Okay, and bam, magically now the caller is gonna send this message through this guy, and this message object is gonna be received by the service that is being called. Okay. And again, once the the service that is being called is gonna get a message. How does it get the message? Again, this is an instance, this message here. Well, let's go back one slide. Here it is. Okay, so the message is eventually received by the handle message, and then here you can check what kind of message is this, and so forth. All right, quite complicated. Now, for sure is not going to be clear, and I try my best to explain this right. And if you listen to this, this part again and again, you're going to realize that I've said the same things multiple times in different ways. Again, that's to, increase the likelihood that what I'm saying somehow resonate with you and you get it. But again, I think that the right way of doing this is to somehow, try to draw a diagram, try to understand, okay, I call this, then this should be called, then I call this, and so forth. And then there is a challenge that somehow forces you to do this, okay? There is a bad news. The bad news is that the example I just described only allows client to service communication. So if the client, you send this message, then the service has some kind of method, like in this handle message, that somehow, can check, oh, is this message of type hello? Is this message of type Peppa Pig, and so forth? And then it can reply. But it's not the classic, it's not like the service can now initiate and send a message to the client. So the client sends something to the service and the service replies, okay? But the service cannot initiate anything and send anything to the client, okay? So this is just a communication one way. And if you have the service that needs to send back a message and maybe somehow initiate the sending a message, then the client needs to create a messenger in the client. Long story short, basically you need to replicate what I'm saying, but on both sides. Now, there was the bad news. The good news is that there is somehow kind of working example from the Android documentation that somehow explains and shows you in comments on how you're supposed to do this kind of double direction communication. That was a good news. The other bad news is that there is a challenge that actually forces you to do this kind of two-directional stuff. So have fun. Cool. So moving on. Are there any questions about this? I'm sure there are questions. It's not that simple. No questions? Is there a question maybe? No question. Okay, fantastic, super clear. All right, so moving on. We're going to now talk a bit about these broadcast intents and receivers. I've been mentioning broadcast receiver some slides ago, where basically you have these components that somehow they can declare, please wake me up when there is event of type X, okay? And so even if the app is not running, and when there is an event X, the app, the framework is gonna say, hey, this app contains a receiver that wants to be woken up when there is event X. Now let me wake it up, and let me deliver the event X, okay? Now the question that I want to answer with this slide is, how can an app send a broadcast intent or a broadcast event of the type that can wake up broadcast receiver? Well, there is a method called send broadcast. So you create an intent with a type of action, type of event, and again, it's just an intent. And that's exactly what happens when the framework sends around, battery is charging, or or user is present, something like this. Okay, and you send it around, bam. At this point, the relevant broadcast receivers are going to be woken up. Okay, I mentioned last time that if you install an app and you don't run it, this mechanism is not triggered. Okay, so the mechanism of, oh, I am waking up when there is event of type X only triggers if the user already manually started the application at least once. okay? So that you cannot just install the malware, and then the malware automatically starts whenever it wants. But basically, the user needs to start the malware manually at least once for this mechanism to be triggering. Okay. But okay, you get the idea. You create an intent. You do send broadcast. You send it around, and then the relevant receivers are going to be working. Great. Now, I mentioned last time that a receiver can declare to the system, you know, I would like to be woken up when event X happens. And you probably remember that intent filters are the, you know, the type of things that come into play. And we discussed intent filters for activities and for services. And, you know, intent filters were also relevant to declare, hey, I would like to be woken up when there is action X for broadcast receivers. It turns out that this intent filter via manifest, which is what I showed last time, is not relevant anymore for broadcast receivers. So basically, if you have an app that targets API level greater than 26, so it's already some versions ago, then the intent filter defined in the manifest does not longer apply, does not work anymore. Okay, so please pay attention to this, because there is a challenge for which somehow you need to declare, you know, you need to create a broadcast receiver that somehow waits for event of type X. And if you check some old documentation, you're going to see, oh, put an intent filter in the manifest. That's not going to work anymore. Your app is not going to be waking up when there is an event of type X. Okay. So how do we do it then? Well, with receivers, you can declare intent filters at runtime. So the way you do it is the following: you take the instance of this receiver, and then you can create an instance of the class intent filter. Again, it's an Android framework object. And once you have this, then you can call the API register receiver. So that's how at runtime you can associate an intent filter to a receiver. Okay. After this, if there is a broadcast intent sent around the system with action some action, then your receiver is going to be woken up. Okay. So please remember this, because it's actually interesting that for receivers, that's the only way it works. You need to do it dynamically. And this dynamic stuff, you can do it only for receivers. So you cannot register intent filters at runtime for activities or for services. Okay? Cool. All right. More info on bundles. I have mentioned bundles in the past. Now I would like to go a bit deeper into them. You remember last time I talked about intents, and I said you can add some data to intents. Well, it turns out that bundles are the actual way that you associate data to an intent. So somehow each intent has a bundle, and a bundle is simply a wrapper around the key value store. What does it mean? Well, it's a data structure that somehow associates a value to a given key. Now, for these bundles of Android, again, bundle is an Android framework class. So if you Google for it, you're going to find documentation. A bundle is a key value store. The key for these bundles needs to be of type string. Okay, and the value can be any class that is serializable. What does it mean serializable? Well, check the slides from last time. Again, it needs to be a class that implements either parcellable or serializable, but somehow the system needs to know how to convert the instance of a class in a series of bytes. Okay, and then you can do something like this. Let's say you have a bundle, you can do put string flag. Here is my flag. What does it mean? Well, you're adding an entry, a key value entry, where the key is the flag, is the string flag, and the value is the string. Here is my flag. That's how you put a string as a value. Again, the type refers to the value here, the type of the value. The type of the key is always a string. So if you see bundle.putInt, well, you know that you're associating to a key of type string an integer. That's how the int here is. Okay. And in this case, basically, you have a key value entry, the key is num, and the value is the integer 42. If you check documentation, you're going to see methods for basically all the different data types in Java. Okay. Now, we have seen last time how to add data to an intent, but we did not comment on the methods of the bundle. How is it possible? And am I saying something wrong when I say that each intent has a bundle inside, and the bundles are the way intent somehow contain and store information that is to be sent to the receiver? No. So what's going on is that, again, each intent contains a bundle, and then in the intent class, the Android framework team implemented a bunch of methods. There are somehow wrappers around methods of the bundle. So for example, you can see apps that can do something like this: intent.putExtra flag value. What is this? Well, this is basically under the hood. This putExtra is somehow getting a reference to the bundle that is pointed to by this intent, and is adding a new key value entry where the key is flag and the value is flag value. Same for this putExtra, is getting a reference to the bundle underlying the intent, and is going to put the entry for the value 42 associated to the key now. Okay? And then there are other methods to actually get this instance of the bundle. So for example, if you receive an intent, what you can do is to call get extras. Bam, now you have a bundle object. Now you have a bundle object, check the documentation. There are ways to get a string associated to the value flag, or get the integer associated to the value num, and so forth. Okay. So rephrasing it, what I'm saying is, once you receive an intent, you can get a reference to the bundle, and then this bundle can contain a number of key value entries. There are methods to list all the key value entries, so you don't need to guess which key is the correct one, so you can list them all. And once you know the key, you can do get, I don't remember the thing, but check the documentation. If you want to, for example, if associated to the flag, to the key flag, you have a value that is also string, I think you can do bundle.getString, and you pass flag, and the output is going to be the value associated to the key flag. Okay. So again, once you get the intent, you can get the bundle, you can list all the entries, and you can get all the values contained in this bundle, and also in this intent. Why am I being so annoying about this? Because of course there is a challenge for this. Okay, but you know, it's such a frequently used object and abstraction in Android apps that is very, very important that you get it right. Cool. All right. Another thing I want to clarify is, let's say that you have an app that and you want to send an implicit intent. Let's say that you have the question, which app can reply to this implicit intent? Okay, so let's say you create the implicit intent, and then you say, well, implicit intent of action view. Okay. Then in Android, there is a way to somehow enumerate which target activities or service or whatever can reply to this kind of implicit intent. Okay. The way you do this is to get reference to the package manager, again, which is some kind of Android class. And there are ways to somehow enumerate all the target components that can answer a specific question. Yeah, I also have a snippet of code. So you get a reference to the package manager like this, given the context.get package manager. And then you can do pm.query intent service. Again, this is all well documented, and somehow you can iterate over the components that can serve, that can reply to an implicit intent of a specific kind. So again, this is a reference to an intent, and the intent is going to contain an action and so forth. I want to spend a couple of words on this context. That's something you're going to see very often. Somehow there are many methods that should be invoked on the context object. The context, you can see it as a reference to many important things, and usually there is get package manager, you can do context.get resources and so forth. The question is how, let's say that you have code in your own create of an activity, how can you get a reference to the context object? The tricky part is that the activity itself is the context. So what does it mean? Well, if you check the documentation, when you create the activity, you usually do class pep activity extend activity. If you check the documentations of activity, you're going to see that the activity the class activity extends the class context. Okay, so once you have an activity, the this pointer points, of course, to your activity, and this is also an instance of the context. And that's why in the past example, in the past demo, what we've seen was, oh, you can do this dot get resources. Is because this is a context instance, and from the context instance, you can get reference to the resources. Okay? So in many cases, through documentation, it should be context dot get something, but then in practical code, you're gonna see this dot get something, and that's because the this is also a context. Okay? I'm not lying, check the documentation to figure this out. Cool. Okay, so this was the last slide for this slide deck, and I'll see you in very, very shortly. I have last slide deck for today, and then we are done. Okay, see you in a second.